As chemical engineers, we spend a lot of our time talking about balances, whether these balances are on mass, moles, energy, or as we'll see in our future, entropy. And so in this video, I want to give at least a precise definition of what a balance is and why it can be useful. And so a balance is essentially a tool that we use to study the accumulation of a property or a quantity within a system. So the accumulation of any quantity, really, within a system can be described by a balance. And so, let's consider the scenario that I'll sketch out down here. Let's say we have some sort of system that has a boundary marked by the dashed line, and then everything outside the boundary we'll call the surroundings. And so, for a balance of any quantity for the system, we could write it as accumulation is equal to input minus output plus generation and consumption. Okay? And so the way to think of this, these inputs and the output terms, this is going to be for any quantity that crosses the system boundaries. And so if it's mass, it would have to be a mass flow rate that's going into the system or a mass flow rate going out of the system. All right. Now, these generation and consumption terms, these all happen entirely within the system boundaries. And really, the way to think of these generation and consumption terms is combined. You could call them, or think of them as a creation rate. You know, what is the rate of the quantity of some property that's being created within the system? And so, if we think of a quantity that's conserved, such as mass or energy, so these conserved quantities, the creation rate, the generation and consumption of specifically mass or energy, that has to be equal to 0. Okay? So that's just what the first law of thermodynamics is actually telling us, and what the conservation of mass is actually telling us, is that if we did a balance on those two properties, generation and consumption would have to be 0. But there are other sorts of quantities where the creation rate is not 0. Or in other words, the quantities aren't strictly conserved. You could actually create them or consume them, depending on the quantity. So the creation rate. So some examples of where the creation rate is not equal to 0 is one that you're very intimately familiar with, is the moles of a species in a system that's undergoing a reaction. Right? So if methane was reacting with oxygen to form carbon dioxide and water, the moles of methane would not be conserved. They would actually be consumed in that process. And the moles of the carbon dioxide would be generated. So that's one example of where the creation rate is not equal to 0. Another example is going to be a property in which we call entropy. And specifically, whenever we have what we call an irreversible process, entropy is it's not going to be conserved, it's actually going to be generated. And so for both of these things, we're going to cover them later in the course. So we'll explore later. But in any case, to describe these properties, we could use the same sort of tool that we use for mass and energy, which is our very trusty balance.